Welcome back. In this tutorial we're building a fully modular AAA compass system in Unreal Engine 5 using blueprints. We'll create a reusable compass HUD that's easy to drop into any project. If you want the full project files and bonus content, check out my Patreon below. Let's get started. Inside your content browser, right-click and create a new folder called Compass. Open that folder, create another folder inside it, and name this one Core. Now inside the Core folder, right-click and go to Blueprints, then create a blueprint function library. Name it bfl_compass maths. Open it up, and we're going to create our first utility function. Rename the default function to normalize yaw. Select the function, then over in the Details panel add an input called yaw and set its type to float. After that, create an output called degrees, also set to float. From the yaw input, drag out and add a normalize axis node. This keeps the rotation values clean by converting them into a consistent range between negative and positive angles. From the return value, create a less than node and check if the value is less than 0. We'll use this to detect negative rotations. From that boolean, add a select float node and connect its output into the degrees output. Now take the return value from normalize axis again, and create an add node set to 360. Connect this result into A on the select float, then connect the original normalized value into B. What this does is convert negative yaw values into proper 0 to 360 degree compass values, giving us cleaner directional readings for the HUD. Next, create another function called getDirectionFromDegrees. Select the function, add an input named yaw and set it to float. Then create an output named direction and set its type to text. This function will later convert degree values into compass directions like north, east, south, and west. Inside the getDirectionFromDegrees function, drag from the yaw input and add an in-range float node. Set the minimum to 337.5 and the maximum to 360. Duplicate that node and set the second one to a minimum of 0 and a maximum of 22.5. These ranges represent north on the compass, since north wraps around both ends of the 360-degree rotation system. Combine both range checks using an or boolean node. Then connect that into a branch. From the direction output, create a make literal text node and set the text to n. This will allow the function to return the correct compass direction whenever the player is facing north. Now duplicate in-range nodes and connect the yaw input into its value pin. Set the minimum to 22.5 and the maximum to 67.5. This range represents the northeast direction on the compass. From the false output of the first branch, create another branch and connect this new range check into its condition. Then duplicate the existing return setup from the north direction and connect it to the true output of the new branch. Change the text value to any. This setup allows the function to continue checking additional directional ranges if the player is not facing north. Duplicate the relevant nodes again and connect the yaw input into the value pin. Set the minimum to 67.5 and the maximum to 112.5. Connect the previous false execution pin into this new branch, then change the text output to E. This range handles the east direction, allowing the function to continue stepping through compass checks in order. Now duplicate the same setup again, connect the yaw input into the value pin. and set the minimum to 112.5 with the maximum at 157.5. Connect the previous false pin into the new branch and change the text output to SE. Duplicate the previous direction check nodes again and connect the yaw value into the new in-range float node. Connect the previous false output into this new branch. Set the minimum value to 157.5 and the maximum value to 202.5, then change the return text to S. Duplicate the same setup again and reconnect everything. Set the minimum value to 202.5 and the maximum value to 247.5, then change the text to SW. Repeat the process again. Set the minimum value to 247.5 and the maximum value to 292.5, then set the text to W. Duplicate the nodes one final time. Set the minimum value to 292.5 and the maximum value to 337.5, then set the text to NW. After the final branch, connect the false output directly into the return node. This acts as the fallback path if none of the direction ranges are matched. At this stage, the compass is now dividing the full 360-degree rotation into directional zones. Each range represents a compass heading, allowing the system to dynamically convert player rotation into readable directions like N, SW, or W in real time. Go back to your compass folder, right-click, go to User Interface, and create a widget blueprint. Rename it to WBP_compass, then open it. Add a canvas panel, then drag in a vertical box. Anchor the vertical box to the top middle of the screen. Set its position X to -70, position Y to 48, size X to 142, and size Y to 103. Inside the vertical box, add a text widget and rename it to txt_direction. Enable is variable on the text block, then set size properties to fill so the widget scales correctly inside the layout. Change the displayed text to N. Under the font settings, set the typeface to light, then increase the font size to approximately 50 for clear readability. Set the justification to center, then add a new text block to the canvas panel for the next compass direction element. Rename the text block to txt_degrees. Enable is variable and set the vertical alignment to bottom. Change the text to 000. Set the font typeface to light, the font size to 20. The justification to center, and the letter spacing to 200. Go to the event graph and create a new function called UpdateCompass. Inside the function, drag in txt_direction and choose Set Text. Select the UpdateCompass function, then in the Details panel add a new input called degrees and set its type to float. Add another input called direction and set its type to text. Connect the direction input directly into the in-text pin on setText for txt_direction. Now drag in txt_degrees and choose setText. From the degrees input, add a round node so the float becomes a whole number, then connect the result into the text input. Unreal will automatically create the conversion from integer to text. Navigate to your core folder, right-click, and select Blueprint class. Choose Actor Component, then rename it to BPC_compass and open it. Create a new variable named Widget class. Change the variable type to WBP_compass class reference, then enable instance editable. This variable defines which compass widget will be spawned by the component. Set the default value to WBP_compass. Add another variable named compass widget and set the type to WBP_compass object reference. This variable will store the active widget instance once it has been created at runtime. Create a new variable called playerIndex with the type set to integer. Enable instance editable so different local players can be assigned if needed. Create another variable named AutoCreateWidget and set the type to Boolean. Enable instance editable and leave the default value set to true. This allows the component to automatically create the compass widget during initialization. Add a variable named ZOrder with the type set to integer. Enable instance editable. This controls the widget's layering order on the viewport. Create a Boolean variable called UpdateCompass and leave the default value set to true. This will later control whether the compass updates dynamically. Create another Boolean variable named controlRotation and set the default value to true. When enabled, the compass will use the controller rotation instead of the actor rotation, which is typically preferred for camera-based movement systems. Finally, create a variable named rotationSourceActor and set the type to actor object reference. Enable instance editable. This provides the option to override the default rotation source and drive the compass from a custom actor if required. Drag an AutoCreate widget and create a branch. This lets us decide whether the compass widget should be created automatically when the component starts. Drag in widget class, then from it create a createWidget node. Connect the true pin from the branch into createWidget. Now drag in playerIndex, then create getPlayerController. Connect the playerIndex into the playerIndex input, then connect the return value into owning_player on the createWidget node. After createWidget, add setCompassWidget and connect the created widget return value into it. Then drag from CompassWidget and call addToViewport. Connect your ZOrder variable into the ZOrder input. This stores the widget first, then adds it to the screen using the layer order we set earlier. Now right-click and add event tick. Drag and update compass and create a branch. This gives us a simple toggle so we can enable or disable live compass updates. drag in compass widget and add an isValid node. Connect the true pin from the branch into isValid, so the compass only updates if the widget exists. From isValid, continue into your compass calculation. Drag in player index. Create get player controller. Then from the return value get control rotation. Break the rotator and use the z/yaw value. Connect the yaw value into normalize yaw. This keeps the angle clean, usually between 0 and 360, instead of using negative rotation values. From the normalized yaw, call get direction from degrees. This converts the degree value into a readable direction like n, NEE, or SC. Finally, drag in compass widget. Call your update compass function. Then connect the direction output into direction and the normalized yaw into degrees. This sends the final compass direction and degree value to the widget every frame. Now all that's left to do is open your character blueprint and drag the BPC_compass onto it. The compass will automatically create and update at runtime. Because the system is fully modular, you can simply migrate the compass folder into any future project, add the component to your character, and it'll work straight away. And that's gonna be it for this tutorial. If you enjoyed it, make sure to like and subscribe, and check out the Patreon below for project files and more modular systems. Thanks for watching, and I'll see you in the next one.